Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out, guys. This is video number 12, which simply means I'm doing question 12 from the promised 33 questions, and all of them, guys, they are extracted from past exam question papers. Please do attempt all of these questions. You can take a screenshot, try it on your own, and then come back to compare your answers with mine. Okay, we are told that the table below shows the boiling points of four organic compounds represented by letters A to D of comparable molecular mass. Compound A is butane, and the types of intermolecular forces that exist with butane, we have London forces, or they are called dispersion forces. Nah? Then compound B, let me use a different color. Compound B, we have propanol. Propanol is an aldehyde, and aldehyde has dipole to dipole forces. And then compound C, we have propan 1-ol. Propan 1-ol has hydrogen bond, as well as ethanoic acid. It also has hydrogen bond. The difference is that carboxylic acids have two sides of hydrogen bond, which makes it stronger than all the other organic compounds. Okay, let's answer the questions. Remember that, guys, were given the boiling points, and the one thing I want you to know that there is that the higher the boiling point of an organic compound, it simply means that that organic compound will have stronger intermolecular forces. Are you together? And the lower the boiling point, the weaker the intermolecular forces. Another thing I want us to remember is that the stronger the intermolecular forces, the lower the vapor pressure. And the weaker the intermolecular forces, the higher the vapor pressure of an organic compound. Okay, compound A. 4.1 rather, we are told that compound A is used as a fuel in gas burners. Is compound A gas, liquid, or solid at room temperature? Compound A is a gas at room temperature. Please note that for hydrocarbons, methane, ethane, propane, and butane, all those four are gases at room temperature, and then the other alkanes within your scope, within your syllabus, they are liquids at room temperature. Okay, 4.1.2, we are being told that the boiling point of an isomer of compound A, how will the boiling point of an isomer of compound A compare to that of compound A? Write down higher than, lower than, or equals to. Refer to the molecular structure, intermolecular forces, and the energy needed to explain your answer. Okay, compound A, guys, we have butane. Né? Our compound A will be like this. Butane is a straight chain hydrocarbon that has single bonds between adjacent carbons. That's butane. It has London forces, and its chain isomer. Did they say chain isomer? It's just an isomer. Okay, it's fine. But the isomer of butane is a chain isomer, guys. Né? It's called methylpropane. Those who want to be fancy, they can say it's isopropane. It's isopropane. Methyl propane. Okay, I'm comparing the boiling point of methyl propane with that of butane. Whenever you name this thing, guys, for you to be safe, yes, you can say 2-methyl propane, but there's no difference because there's only 1-methyl propane. There's no any other methyl propane rather than 2-methyl propane. No? Okay. We can say that, okay, the first thing I want us to know is that these two compounds, guys, have the same molecular mass. Why? Because they have the same molecular formula together. If you would calculate the molecular mass, it will be the same for these two compounds. Okay. Whenever you choose, we'll simply say that the isomer, or you can call it by its name. You can simply say that methylpropane is more branched than a butane. All together. And then since methylpropane is branched and the butane is not, it simply means that methylpropane has weaker intermolecular forces. Weaker intermolecular forces, right? And then hence less energy will be required to separate the bonds and hence methylpropane has a lower boiling point. Alright, good. That's how, guys, we're supposed to tackle that question. Né? But if you wanted to contrast the two by using a butane, it will be the direct opposite of what we've written. However, the answer will still be correct. We'll simply say that if butane is not branched, that simply means butane has a greater surface area compared to methylpropane. Are we together? Then our second point will be that butane has stronger intermolecular forces compared to methylpropane. The third point will be butane will require more energy to separate the bonds. And then the last point would be that butane will have a higher boiling point compared to methylpropane. That's how, guys, you need to tackle these types of questions. Yeah? Okay. And then 4.1.3, we are told that using molecular formula, write down the balanced equation for the combustion of compound A in excess oxygen. The combustion of compound A in excess oxygen. Let me create room for me to write. I hope in the meantime, Bantwana, you are subscribing, lab. Combustion of compound A in excess oxygen. Okay, compound A is butane. You have C4H10 plus oxygen. This will always give us, for complete combustion, simply have carbon dioxide and water. Are we together? By just being able to write down the reactants properly as well as the product, you have 2 marks. The final mark will be you'll find it by balancing the entire reaction. Okay, how do we do that? How many? You must balance the number of elements. Né? How many carbons do you have on the left hand side? We have 4. On the right hand side, only have 1. So I'll just write a 4 there as a coefficient. How many hydrogens do we have? We have 10. On the other side, we only have 2. So if I write a 5 there, I'll simply have 5 times 2, which will give me 10. So the number of carbons is the same. The number of hydrogens is the same as well. Né? All I need to do now is to balance the number of oxygens. How many oxygens do I have? I have 4 times 2, which will give me 8, plus 5. I'll have 13. Whatever number I have here, I must divide it by 2 over here. Are we together? The coefficient of oxygen should be half of this number, always the time. So half of 13 will just give me 13 over 2, Why? Because 13 is not an even number. But we do not write our stoichiometric coefficients as fractions. All I need to do is to multiply each and every term by the LCD. Our LCD is 2. Are we together? So whenever I do that, I'll simply have 2 multiplied by CH4H10, and then over there the 2's will cancel. I'll be left with 13O2. This will give me 8 CO2 plus 10 H2O. Now let me see that everything is balanced. I have, that's 4 guys, actually my handwriting sometimes. Okay, I have 8 carbons on the right hand side, 20 hydrogens on the right hand side, 26 oxygens, 16 plus 10, that's 26. So everything is balanced. So the equation of my combustion is just 2 C4H10 plus 13 O2, giving me 8 CO2 and 10 H2O. That's my complete combustion. Okay, 4.1.4, I'm told that compound A has a lower boiling point. Compound A has a lower boiling point than compound B. Compound A is butane, compound B is propanol. Yeah? Okay. Give reasons for the difference in boiling point by referring to the following: the structural difference between the two compounds and the polarity. The difference is that, guys, propanol has an oxygen atom. Excuse me about that, guys. Propanol has an oxygen atom, ne? The oxygen atom is bonded with the carbon. Excuse me about that. Organic chemistry. Excuse me about that, guys, ne? Okay, but they want us to compare the difference between compound A and compound B. That's why do they have different boiling points. Propanol has an oxygen bond which is bonded to a carbon atom. Are we together? This is an aldehyde. The structure is just like this. Are we together? And hence propanol has polar bonding. Are we together? But butane has London forces only. It's just hydrogens and carbons bonding to one another, is non-polar. So that's why propanol has a higher boiling point. Why? Because compound B has polar bonds. Are you together? It has an oxygen bonded to a carbon. That's why the boiling point is higher than that of compound A. Okay, and then compound. Now let's go to 4.2. Consider the following points of compound C. Consider the boiling points rather of compound C and D. Compound C and D has two different boiling points. We have propan-1-ol and ethanoic acid. Give a reason for the difference in boiling point by referring to the intermolecular forces in each of these compounds. Firstly, these two compounds, both of them has hydrogen bonds. Are you together? However, what makes ethanoic acid to have a greater boiling point is that it has two sides of hydrogen bonds, and that means it will be strong. Its intermolecular forces will be stronger than that of a propan-1-ol, and hence ethanoic acid will have a higher boiling point. All right, together. Now let's go to 4.2.2. Write one of, which one of compound C or D has a higher vapor pressure. The one that has a higher vapor pressure is the one that has a lower boiling point. Between the two, I'm comparing compound C or D. Nah? Okay, compound C will have a higher vapor pressure. Compound C will have higher vapor pressure. All right, together. Why is that? Compound C will have a higher vapor pressure because it's not a second point, rather. Will have a higher vapor pressure because it has a lower boiling point. Remember that, guys, the higher the boiling point, the lower the vapor pressure. Always the time, guys. Do not forget that. Né? Excuse me, guys, about the distraction that happened. I hope the video helps you out, guys. Thank you.